Okay, so 1.6, that wraps up chapter 1, and they always go over key concepts. And actually, at the end of each section, you'll see key concepts. I like the textbook in that it gives great, clear examples. What it doesn't do is give great, clear concepts of formulas. And so it reviews what chapter 1, what you should have covered, which is slope of a tangent versus slope of a secant. Slope of a tangent at any arbitrary point, the difference between average and instantaneous and how to do it, how limits approaching from the left and the right, zero where you can't have something over zero, and continuity. And then they also review the formulas that you should know, okay, over time. And that when you're taking the instantaneous tangent of distance over time, you're actually taking velocity. And there you go. And then it's really important that you do all the review exercises and you spot the ones that you can't do. In chapter 1, this review covers everything. And, always do at least 2. And if you're comfortable with them, do the first and the last one. And if you can't, then continue doing them until you can. Then they give you a test. Now, chapter 2 goes on to derivatives, which is the term for what we just learned. And I want to just do something, and they review some skill sets that are important. And the skill sets are always important to review. And you're going to discover that exponents is huge in this, and slopes of a line. But I want to review something. In the beginning, you learned slope of a line was just delta y over delta x. And slowly that changed into something like this. And it looks different, doesn't it, than what we learned? And that can also be expressed as this. As x approaches a. This one would be a limit as h approaches 0. And these are the same thing as the next thing we're going to learn, derivatives. This is actually derivative. So a derivative is when you take a tangent, you find the slope of the tangent. By the way, this just leads to the slope, and this just leads to the slope of a tangent, and this leads to the slope of a tangent, and derivatives are going to lead to the slope of a tangent. But what we're going to learn is that we don't have to take a specific x over and over again. We're going to learn how to come up with formulas for the derivatives. And why? Because science, very much in very specific forms of science, calculus is applied in measuring the rates of change of things that are difficult to measure. And you might find, depending what profession you go in, that you'll never use calculus again. However, the fundamentals are important for understanding data that you do use in all forms of science. So let's go over some of these exercises. I'm not going to spend too long on them. You can always YouTube, Google information on how to do them at any time. So when you have bases that are the same and they're multiplying, you add their exponents. So that's a to the 8. You just add their exponents. When you have things, in this case this thing's multiplying the other thing, you can learn that you can also cancel out. So we see that 6 times p to the 9, and down here we have p to the 15. They have the same base. So you can now subtract, which one's higher? 15. So what's 15 minus 9? 6. So you got p to the 6. Now you got p to the 7 up here and p to the 6. And we're just left with 1p, right? So this p is gone entirely, and that p is gone entirely. Then just up top, you're left with the numerals. Now the numerals can multiply each other. They have nothing to do with a p. P is just a term for a number that we don't know at this point. And that's why you can just kind of keep them all side by side. So 4 times 6 here is 24. P is all that's left of the p's, all divided by 12. What's 24 divided by 12? It's 2. So the answer to that is 2p. And it's very important that you learn it. Now you can also cancel before you ever multiply. 6 goes into 12 twice. 2 goes into 4 twice. So there's the number that's left. You can even add these first. P to the 7 times p to the 9 is p to the 16. We have p to the 15. That means all these p's go away, and all but 1 goes away here. We're left with 2p. Same answer. A lot easier when you cancel first, and that's what they're teaching you. Before you can add these exponents, you have to follow the rules of exponents. So we have an exponent affecting this bracket. So that means they cannot multiply until you follow the order of operations. Okay, what's going on here? We have 2, that's to the 4, and we have E3, that's to the 4. Well, 2 to the 4 is 16, and E3 to the 4, when you have an exponent of exponent, you multiply the exponents. So you have E12. Now you can multiply it by the thing beside it. It's very important that you don't mix that up. The order of operations applies to everything, no matter what. Now here we can only multiply the numbers. Let's just get rid of that. The number 3 times 16 is 48. And the E has the same base as this E, so that we can add their exponents. So we're left with 48E to the 18. And that's the answer. Don't make the mistake of going this way and multiplying these exponents first. The order of operation says that this exponent is affecting this bracket, which means we must resolve that before we multiply. Great, let's move on. Same thing over and over again. So don't forget that this minus 2 is also to the power 3. Minus 2 times itself 3 times becomes minus 8. And then the exponent here times the exponent becomes a to the 6. So it's minus 8a to the 6. That's all it is. Now, these do not have an exponent outside the bracket, and so we can only multiply the bases that are the same. So we've got a to the 4 and a to the minus 6. Well, the same rule applies. We add these exponents. What's 4 plus minus 6? It's the same as 4 minus 6, which is minus 2. So we're left with a to the minus 2. And then with the b, we have the minus 5 plus the minus 2. What's minus 5 plus a minus 2? The same as minus 5 minus 2, which is minus 7. So we're left with b to the minus 7. Now, it's totally legitimate to leave it like that, but you should understand what a minus exponent is. A to the minus 2 simply means 1 over a to the 2. So that means the a, if it was in the numerator, goes to the denominator and gets a positive version of its old exponent. Same with this b to the minus 7. It's actually 1 over b to the 7. So if I was going to express this fraction without the negative exponents, it would be this. And this is the same, exact same equal sign as that. Remember that. Now also remember this, not that it matters in this case. If I have 1 over a to the negative 2, where's the a? It's in the denominator. That is the same as a in a numerator to the power of 2. So you can see it can go from the denominator up, too. Great. The next one is all about order of operations and cancellations. Okay? You must identify exponents that are affecting a letter first. So for instance, this minus b is to the power of 3, and we'll keep its minus, because a minus to the power of 3 stays a minus. So there's no other exponents going on, so you can go ahead and multiply this bracket out. But let's do some cancellation first. What's minus 4 plus 3? It's minus 1. So we just have a to the minus 1 would be our only thing. Just make it minus 1 up here. And there's no other things. Well, we have 3 and 2. They multiply, and we get 6. So we get 6a to the minus 1 minus b to the 3. Let's look at down below. All right. Can that b cancel? Isn't it a minus b? Yeah, that minus doesn't matter. That minus travels as like a minus 1 in front of the b, so we can just put it up here. So let's look at the b's. There's 3 up here and 2 down there. So the b's, we're left with b to the 1. And then we've got a to the minus 1 with an a to the 5. Well, a to the minus 1 over a to the 5, the rule is we subtract their exponents. So we get minus 1 minus plus 5, which is the same as minus 5. We get minus 6. So up top, we're left with minus 6, a to the minus 6, b to the 1. And down below, there's no more a's. There's just 12. Well, there's one last thing we can do. We're left 6 goes into 6 1 times and into 12 2 times. So we're left with minus 1, a to the negative 6, b over 12, over 6 rather. Now, we can also, we shouldn't even leave that a there because we have a denominator. So we would have minus b over 6a to the 6. So I took this minus 6 and it went down there. And that's your answer. That's your simplified answer. These are important to know. It's important to review your rules for exponents. Otherwise, you can't. The only reason we do it the way it's being done is you can't go to the next section until you understand how to do these things. Here we have the same base, which means I can add their exponents, but you notice they have different fractions as exponents. This one is a square, and I'm adding 2/3. Well, it's the same rule for adding fractions. Cross multiply. I get 3 over 2, or 3 plus 4, all over, when I multiply these base, 6. So that's 7 over 6, which means it's x 7 over 6, okay, which is x 1 and 1/6. Well, we don't need 1/6, so we don't need the 1, so it's just x to the 1/6. And that is the same as x to the 6th root. That's what a 1 over 6 means. The top part is a power, so let's say that was 2 up there. It would be like that. Well, we would simplify it, but anyway, you get the idea. So the top is the power, and the bottom is a root. That's all that means. What about this one? Well, we have to put 8 to the 2/3 as well. So that's the part that's tough to remember. So you do 8 to the 2/3 times x 6, and that now is to the 2/3. So that's how we could rewrite it. Well, for this one, we multiply the fractions. 6 over 1 times 2 over 3. It always helps to remember that whole numbers are just that over 1. 12 over 3, which is 4. So we're left with x to the 4. X to the 4. What about this one? Well, there's no... We can square it first. You're allowed to follow any operations, or we can cube root it first, because 8 to the 2/3 means 8 squared to the 3rd. Doesn't matter which order we go in. Let's take the cube root of 8 first. The cube root of 8 is 2. And let's then square it. 4. So this whole thing simplifies to the number 4. So we're left with 4x to the 4. What about this? How do I subtract? First step you do is you convert it into their proper fractions. So square root of a is a to the 1/2 times, what's a cube root? A to the 1/3, all divided by the square root of a to the 1/2. Now you'll notice that these are the same thing, so they can just cancel out. So you're left with a to the 3rd, which is just the cube root of a, and you can't solve it anymore. It's very easy to see here as well. Determine the slope of the line that is perpendicular to the line with the given slope. Determine the slope of a line that is perpendicular to a line with the given slope. Well, perpendicular lines just have the same slope. So that means it would be 2/3 x, and we don't know the b. And for this one, it's -1/2 x plus we don't know the b. And this one, it's y is equal to 5/3 x plus b. But all they're asking for is the slope. So all perpendicular slopes have the same slope. All perpendicular slopes have the reciprocal with a change sign. So the perpendicular slope of this one would be 3 over 5, -3 over 5. This is perpendicular to that, but a parallel one is 5 over 3. Okay, whenever they're here, they're teaching you how to find a line, and I'm not going to do it necessarily. So assign a value. This is x1, this is y1, this is x2, this is y2. So long as you keep them in order, y2 minus y1 over x2 minus x1 will give you the slope. So we get -2 minus -4, and we get 9 minus -3. So -2 minus -4 is +2. It's the same as -2 plus 4. And minus 9 minus minus 3 is the same as 12. And this simplifies to 1 over 6. So boom, we have the slope. To find the line, you write the line formula. And now we're only looking for b now. Well, put this in for here and take probably the simplest points that you can take for your x and your y. So you got minus 4. So as long as you have a slope in one point, you can figure out the formula. And we got 1, 6. And what's our x? Minus 3 plus b. We're trying to figure that out. What does this simplify to? Minus a half plus b. How do we get minus a half? How do we get b all alone? We have to add a half, because it's essentially b minus a half if I rearrange this. So we have to add a half, which means I get minus 4 plus a half on this side, which is 3 and a half, minus 3 and a half, which means minus 3.5 is equal to b. So I simply put this in. Where I see plus b, I put minus 3.5. And where I see m, I put that. And boom, this is the formula for a line. For b, let's see if they'll let us do b. Well, I can't really clear it up, but it doesn't matter. In b, they're giving you a line. They're telling you it's parallel to this line. And they're giving you a point. Well, we need to figure out the slope of this to figure out the slope of that. So rearrange it in terms of y. So I'm going to move the 2y to this side. I get 3x equals 5 plus 2y. Then I'm going to get rid of the 5 on both sides. So I get 3x minus 5, put it in brackets, is equal to 2y. And now I'm being multiplied by 2y, so I'm going to get rid of it by multiplying by the reciprocal on both sides. Okay, so that's what I'm left with. And really, I'm only concerned about the slope, but I'll do the whole thing. So it expands. I got to expand it. It expands out to 3 over 2x. There's the slope, minus 5 over 2. I don't care about the b of this line, because I'm only searching for the slope, because it's parallel to that line. Now that I have m and 2 points, and 1 point, you do the same thing I did last time. There's a trick. Here they say perpendicular to this line. And the line they give is this. Y is equal to 3/4 x minus 6. What's the slope of this line? 3/4. Therefore, what's the slope of a perpendicular line? Negative 4 over 3, because this was positive. That's the slope of a perpendicular line to that line. And now that I have the slope of the line I'm looking for and a point, I do the same delta y, delta x that I did up here. This is all stuff you should have learned actually in grade 11. This is expansion. They just want you to practice your expansion. I'm definitely not going to do them all, because this is all stuff you should know. If you don't, you better go practice a lot, because you have to do this stuff fast. So here's how you expand. First term times the first term times the second term. Then you take the second term here, and you multiply it by the first term, and there. So you're going to always get two similar things in the middle. So you're going to get 2x squared plus xy minus 6xy minus 3y squared. So where are the like terms? In the middle. Plus xy, so plus 1 apple minus 6 apples. 2x squared minus 5 apples minus 3y squared. You can't really simplify more after that, so because they wanted you to expand and collect like terms. So you're always going to discover the middle terms add up. What about here? Well, first you have to expand here, and then you have to expand there, and then you can subtract them. Okay, where are my like terms? Here and here. So I'm going to end up with minus 13x plus 42y. And that's it. And what about this one? Well, this is just a longer expansion. Practice it. Later on, when you start doing crazy ones, just use Symbolab. But here you should really learn how to expand it. Okay? Here you have to expand this first. And it's a lot easier if you remember the rule for expanding something that's squared. What's the rule? It depends what the symbol is, okay? So it's going to be this squared, which is 4x squared. This squared, which is plus 9y squared. And then 2 times this times that. 2 times 2, 4, times minus 3, minus 12, and then x and y. Boom. It's a lot easier if you can remember that. A lot easier. So the coefficients are 1, 2, and 1. And then you have to square the first term, multiply the first and second term, and square the last term. Look up Binomial Theorem, I think it's called. These are the same thing. Here is something interesting. That's a difference of 2 squares. So when you expand it, you're going to end up with 25x squared minus y squared. And then you can multiply it all by the x in front. But you can really expand these quickly. See, and there's a quick one again too. And this is just first to second, first to second. Simplify. Okay, simplifying is an excellent skill to learn anyway. Why go through all the calculations when you can cancel up top and up bottom? So what's the rules for cancellations? Well, I cannot cancel an x like with this x because this is x plus 2. That's why it's important for things that are being added to put them in brackets. But everything else is multiplying. Like this whole thing is multiplying that. So if I look up top, let's simplify the top. It might make my life easier. So 3x times 5x cubed is 15x to the 4. 15x to the 4. Down here, x squared plus 2x squared, 2x is 3x squared. Great. Already, I can see I have x to the 7 divided by x to the 2. So I'm just left with x to the 5. And I have 15 divided by 3. I'm just left with 5. Now, I'm left with this up top. 5x squared times this divided by this. Very easy to see that these are cancel out, and I'm just left with that. So simplification is a good skill to learn, and sometimes you'll want to learn it. Well, this is the same as saying I have this entire fraction divided by this entire fraction. What's the rule? I keep the first fraction the same, and I multiply by the reciprocal of the denominating fraction. So I multiply instead by this. Right away, I can see the 5 is going to cancel into the 10, and I'm going to be left with 2. And I can see I have 3 of these and 1 of these. So this one's going to be left over, gone, and this one's going to be left with 2 as well. Something to the power of 2, though. And I can see right away that this cancels out with that. So far I'm left with 2 over x plus y to this 2. Now I could expand the bottom, but I don't really see the point. And learn how to expand quickly. But this is probably the simplified form. I'm not going to do the rest, except that when you minus fractions, their denominators must be the same. So again, that's why it's important to do this, because I can't cancel top and bottom when I'm subtracting them, only when I'm multiplying them or dividing them. So how do I get this fraction to include that? And how do I get this fraction to include that? Well, you cross multiply. You're multiplying this numerator by that denominator, this numerator by that denominator, and these two numerators or denominators are multiplying each other. So I'm going to be left with this as a denominator, and this first one is going to be multiplying this denominator, and then minus, put the minus up here, this numerator multiplied by this denominator. Before I can multiply them, or even cancel, I have to expand, subtract, and then see what happens. Let's do that. So, what's the expansion of this? It's x squared plus 4x plus 3 minus everything in the bracket to the right. Okay? minus, so keep a bracket around it because that minus applies to everything on the right, x squared. Oh, difference of two squares, minus 4. Now this minus applies to everything. And I'm going to leave the denominator the same for now. So this minus affects the x squared and the minus 4, and it becomes minus x squared. Sorry, minus x squared plus 4. Great. What cancels out here? Well, x squared minus x squared. The 4 and the 3 can add together, so I'm left with 4x plus 3 up top. And I believe that is the best I can do. And all of that is over that denominator. Now sometimes you're going to discover something like this, which they didn't do. Did I get the I don't think I got the denominator wrong. Sorry. X squared cancels out. I got 4x. I got plus 3. And this minus affects the minus 4. It's plus 4. So I get plus 7. Okay, that's what it is up here. Now, sometimes you're going to have instead cancellations again. Like you're going to be left with x plus 3 up here. And you can discover they cancel, and you're left with that. Maybe they did. Maybe I didn't do my expansion properly. But I don't think so in this case. This addition is the same thing. You got to cross multiply the numerators in order to have a common denominator before you can ever add them. Then you expand and see what you can cancel out. This is all stuff you should have learned in the last 2 years. And this, keep in mind, is the same as saying this fraction divided by this fraction. So you simply multiply by the reciprocal. And then you can see if things cancel out. So right away I can see this cancels out with that. And I can see I'm left with 8 up top and 9 at the bottom. Can't be simplified. That's the answer. Okay, and then they want you to remember how to do factoring. Make sure your factoring's on point. Factoring is huge in this. Okay, what do we have going on in this first one? Well, does this have a square root? Yes, it does. Does this have a square root? Yes, it does. So we're dealing with 2k plus 3, 2k minus 3. It's a difference of two squares, and that's what it always factors out. You put the square root here, you put the square root here, one of them has a plus, one of them has a minus. Difference of two squares, that's what it looks like. That's how you spot it. What about this one? Is there a number that multiplies out to minus 32? That adds up to plus 4. Well, we're going to be dealing with a minus and a positive number, and they're going to be close together. So it's probably like, let's see, 16 and 2, no, 8 and 4. 8 and 4 is what it's going to be. It's going to be positive 8 and minus 4, which means the factors are x minus 4, x positive 8, and if in doubt, expand them and see if you get back to that. Great. What about a more complicated factoring? All right. Yep. This time we're not looking at something that multiplies out to minus 7, but rather something that multiplies out to minus 21 and adds up to minus 4. So we're talking about a minus 7 and a plus 3. It multiplies out to that and adds up to that. You can do the slip and slide method. Plus 3, a minus 7, and then you've got to take this 3 and divide both of them by it. And obviously this becomes plus 1, but always verify afterwards. Obviously this becomes plus 1. And this other one becomes a 3 in front of it, because you can't divide it, slides up in front. Always make sure, though, that becomes 3a squared minus 7, minus 7a plus 3a. Yep. And then finally minus 7. So that does indeed expand properly. So the factors of this are 3a minus 7 and a plus 1. If you don't like the slip and slide method, remember your grouping. Your grouping says you're going to divide this middle fraction into the two factors you discovered, which was minus 7 plus 3. So grouping works like this. Actually, let's put it in different order. And what did I do there? Well, I broke, if you look at plus 3a minus 7, that's what minus 4a is. Then over here, I see I have 3a out of both of them, and I'm left with a plus 1. And over here, when I take 7 out of both of them, minus 7 rather, I'm left with a plus 1. Now these have in common, so I can factor a plus 1 out, and I'm left with 3a minus 7. And that's factored by grouping. Slip and slide method just speeds it up. Okay, and you might say, oh, that doesn't have anything. Yep, the square root of x to the 4 is x to the 2. So it's x to the 2 plus 1 times x to the 2 minus 1. And don't stop there, because we have another difference of two squares right there. So we're left with x plus 1, x minus 1. And boom, that's the factored version of that. Oh, you better remember your difference of cubes too. Difference of cubes, you can Google it. Says that we're going to come out with x minus y. Now we're going to have x squared plus xy plus y squared. And if in doubt, expand it. See if you get back to that. And what do you do there? Well, you keep the same signs here. Then you square the first one. You square the last one. You have a plus here. And this is always going to be opposite of that. And it's simply the two terms times each other. A plus cubed does the same thing. What about this one? Woo! Well, we're still looking for a number that multiplies out to 4 but adds up to minus 5. So we're talking about minus 1 and minus 4. And we're talking about r squared minus 4, r squared minus 1. Then here we have a difference of squares. Oh, we got a difference of squares twice. Okay. So I'm going to put this a bit like that. So here we're talking about r plus 1 plus 2, r minus 2, and here we're talking about r plus 1 and r minus 1. And if you had multiples here, like if I had r plus 1 twice, I could just put a square. But I don't. I have 4 distinct factors for this. And be careful, because you might stop there and lose a couple of easy marks. Oh, factor theorem. Okay, so look up your factor theorem. It's well worth it. But it's complicated, and there's a lot better techniques out there for factor theorem. I'm going to isolate it so I can show you basically the factor theorem. Here's the factor theorem. Start with a pyramid. And there's actually a nice formula for it too, but I like the pyramid. I find the pyramid is faster. 1, and then I add these two, 2, 1. So this is when I have things that are squared. Okay. Then I go 1. Down here is 1. Oh, sorry, these two add up, 3. These two add up, 3, 1. So that's the power 3. So that would be this one. And this is just difference of cubes anyway, so I can just do my difference of cubes. A squared plus AB plus B squared. So that's that one. But let's go on to the 5 one. Okay. And for this one, yeah, you're going to have to look up the actual theorem, because it'll give you a formula for this. And actually, when you get really big into the 5 or into the 7s, yeah, it's worth knowing the theorem. But the pyramid is also a good way to. 1. So this is for the 4, and this is 1 is for the 5. So this one would be for this one. So what are my things here? A, just 1A, and B. And actually it's negative B, right? So I'm going to get A, AB, 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 6 terms, AB, and then B. And this is going to be a to the 5, and this is going to be b to the 5, and actually I have one too many, I think. And this is going to be b to the 5, and then this is going to be a to the 4, b to the 1. It's going to be a to the 4, 3, b to the 2. This is going to be a to the 2, b to the 3. Oh no, I need even more. And this is going to be a, b to the 4, and finally b to the 5. And if you look at the last one, I believe it's going to be minus, 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 because this minus term in front. Maybe it's, I might have this minus wrong, actually. 1/4 minus 1. Oh, actually, you know what it is? So when it's b to the 0, it's still positive. When it's b to the 1, it's minus. When it's b squared, it's positive. When it's b cubed, it's minus. When it's b to the 4, it's positive. When it's b to the 5, it's not. Just to make sure, A5, I'm going to go to Symbolab. Just because my factor theorem is not that good. And I'm going to factor. Beautiful thing here. You can just say factor a to the power of 5 minus b to the power of 5. And I'll show you the steps. Yeah, it goes positive, 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 positive. Oh, okay, they're all positive. Oh, they factored out an a. They factored out an a minus 1, a minus b at one point. Oh, they did the difference of cubes. Well, no, that's not what I wanted to do, though. Theorem. Oh, that's not the right term. Sorry, it's not called factor theorem. Oh, yeah, it is factor theorem. There we go. I got the wrong thing. There we go. If polynomial fx is divided by xa, the remainder of fa is equal to x minus a qx. So it just goes on forever. So looking at Symbolab's answer, which was actually I shouldn't have deleted it. Let's see if it's still there. Yeah, it's very similar. We've got A4, A3, and with B1, A2, B2, A3, B4. And once I factor that out. Well worth looking up. My apologies. I was using the expansion. Yeah, I don't know what I was thinking there. I know what I was thinking by mistake. Sorry, this pyramid does not apply. The pyramid would be applying if I was doing this. My mistake. So factor theorem says that I'm taking a minus b out, and it's very much like the process I did for difference of cubes. Look it up. Factor theorem. Oh, yeah, so in this case it always has a minus 1, but the factor theorem, what you're supposed to do is you're supposed to determine a factor by plugging in, like, is a minus 1 a factor, i.e. when a is 1, is it a factor? So you plug it in to see if it'll work. But I think for this, you know automatically that a minus 1 is a factor. Okay, but for factor theorem, you'd normally have to plug it in to determine factor and then do long division. Okay. Again, still look it up. It's well worth. They're all shortcuts to it. Evaluate. So this just means take 2, put it in wherever you see x, and evaluate. Whatever is in this bracket, even if it said a plus b, you'd replace x with a plus b in a bracket. Rationalize. Okay, so this is very much the thing we were doing with conjugates. This is when you want to change your denominator or your numerator to something that doesn't have a radical in it. So if we don't want the square root at the bottom, and this is, you'll see in cosine values a lot too, we're going to multiply by 1 in this format. What does this become at the bottom? 2, and this just stays like that. Boom, I now have a non-root at the bottom, and this is the same number as that, just written in rationalized form. And since they're asking for the denominator each time, just focus on the denominator, even when there is a root on the top. Okay, when I multiply the bottom, it's just going to become 3. And at the top, I'm going to get 4 square root of 3 minus square root of 6. That's what happens when I expand that into both of them. You can multiply numbers inside roots. Okay, what about this one? Well, this one is when you use a conjugate. That's why we're doing conjugates. So what's the conjugate of that? It's the same thing, but with a plus side. Inside. What's the square of that? 9. What's the square of that? 16 times 2, which is 32. And you put a minus between them. So what's 9 minus 32? It's minus 13. No, minus 23. Minus 23. So that's solved. Now what about the top? Well, you distribute it. So this is the denominator. And 2 times 3 is 6. And 2 times 4 is 8 square root of 2. Plus, now we distribute it this way, plus 9 square root of 2. Plus, this way, 12 times 2, which is 24. Now, what are our like terms? Here and here, so we get 30. What are like terms? We can add these apples with these apples. We get plus 17 square root of 2 over minus, and since the minus can go up here, over 23. This cannot really be simplified with this in any way, shape, or form, and this cannot be solved. This is accurate like this. You would never find the decimal version of this multiplied through and add them, because then you get inaccurate. Okay, what are they asking here? Well, they're going to ask you to take small values of h for it, but we're going to make a is equal to 2. Okay. So this is the function here, and wherever I see x, I'm just going to put 2, because we're talking about 0.2. Well, let's first solve it. When x is 2, this becomes 412 minus 6, which is 6. So 6. And now we're going to solve it. So we're going to rewrite it. It's all over h minus 6, which is this. But instead of a plus h, we're now going to do 2 plus h, because we're making a2. And wherever you see 2 plus x, I put 2 plus h. And I must expand it. So the expansion of this becomes 4 plus 4h plus h squared, all multiplied by 3. So that becomes 12 plus 12h, 12 plus 12h plus 3h squared. The expansion of this becomes minus 4, minus 2h, all of it minus 6. So that entire top here can be replaced, and I might have to do this in 2 parts because I have a tutoring session. And now you're going to look at your like terms. Well, 12 minus 4 minus 6, and there's supposed to be a minus 2 in there somewhere. So I think I did something, because these numbers are supposed to cancel out. So I probably did a minus 4 minus 6, and I get 4 times 3 is 12. So these numbers are supposed to cancel out, I think. So I'm going to have to just do it again, I think. Make sure. So when I do 3 times 2 plus h, the expansion is 4 plus 4h plus h squared, and indeed I get a 12. And then in the second part, minus 2x becomes 2 plus h, I indeed get a minus 4. And now the big question is, what did I do wrong with this? So when 2 is in here, it's 3 times 4, minus 4, That's why it's not 6. It's 8. Okay, there you go. So I get 12 plus 12h plus h squared minus 4 minus 2h minus 8. And the 12 and the 4 and the 8 cancel out, and I'm left with, oh, and this 12h minus 2h, I'm left with h squared plus 10h. All over h. You can see the h can go through here, and I'm left with h plus 10. So as h approaches 0, I get an answer of 10. So I get 6x. Yeah, so that's the answer. Sorry, small arithmetic errors will make you frustrated. I'm not going to do it for as h approaches 0.1. All you do instead of putting in a magical h is you put in a 0.1 up top and at the bottom. And you're going to discover something similar. It's going to be close to 10. Explain what the value determined in part B represents. It represents as you approach or approaching the tangent at that point, but not quite. Okay, I'm going to stop there. And would you believe it? That's just the warm-up for Chapter 2. So